Now I would like to introduce Chasm Regular and the man who taught me everything I know about the weather, Professor Bill Selby.
First thing we're going to talk about is what's going on this year. And you know, everyone's heard about El Nino this and El Nino that. Today I hit the light red and I had to stop for 3 minutes and I thought, well, great, it's El Nino's fault, right? So anyway, this graphic is pretty clear and it shows you why we're so concerned about what's going to happen this year. Now this is being filmed and of course it's 86 degrees outside today on November 22nd. It was 89 in Santa Monica yesterday. And this is not unusual for a Santa Ana wind condition. It's just a little bit warmer than usual when we have Santa Ana wind conditions in late November. Anyway, I'll get back to that in a second. This is a graph that shows previous years of rainfall in the Los Angeles area. It's about 14.5 inches for our region. Believe that or not, we get 14.5 inches of rain on the average. I know it's hard to believe after 4 years of drought. And on the left, you see all of the La Nina years. Those are years when the Eastern Pacific was cooler than normal. And you can see, generally speaking, on the left-hand side there, we get less rainfall than the average when the ocean temperatures in the Eastern Pacific are cooler than average. If you go to the right there, you see all of the El Nino years. And you can see as you make your way toward the right, the general El Nino years tend to be wetter than the La Nina years. And then when you go way over to your right, you finally get to the year that we're in, which isn't on there yet, but here's where I'm going with this. Those 4 bars that you see are the 4 greatest El Ninos in history. Does anyone see a trend? All right. And if you look at the last 2 bars, those are the 2 greatest El Ninos we've ever had, where water temperatures in the Eastern Pacific were warmer than they'd ever been. It was in 1983-84. Some of you might be old enough to remember that. Thank you, 83, 84, and then 82, 83, yes. And then the other one was 97, 98, and there's a lot of people in here that remember that one. And before you get all upset with me, I wanted to remind you that up to December of 97, 98, which was the last big El Nino, people were saying, where's El Nino? You know, I don't see any El Nino, you know, like sort of what you're saying right now. So those are the 2 biggest El Ninos in history, and the one we have working right now is at least as big as those. So this is historical, all right? This is one of the biggest we've ever had, and what that means is that the water temperatures are as warm as they've ever been in the Eastern Pacific Ocean. Now, what does that mean? If you look at the white up here in the upper right, you can see Mexico and you can see Baja California sticking down. And we've got 2 things going on that are rather unprecedented. The Eastern Pacific El Nino is warmer than normal, as I mentioned before, far warmer than average. But we've also had this big blob off the California coast. Have you all noticed the big blob? Anyone who's been in Santa Monica all summer, we've had temperatures and dew points, particularly overnight, that are unprecedented. Dew points up in the 70s. That's like Florida weather. Did anyone notice but me this summer? It was pretty remarkable. And for those of you who are new to Santa Monica, that's never happened before. Now, whether or not that's related to the big El Nino we're having is the question. But the blob has changed our weather too. And it runs its way all the way up to the Canadian border and all the way down to the Mexican border. But again, on the Eastern Pacific and the tropical Pacific, that's how we define El Nino. And those water temperatures, as I said, are running at record levels. And now we're ready for the next slide. Anyway, what I wanted to show you is to answer that question, by the way, is today's satellite image gives you a good idea of what's going on today. We've got a big high pressure system over us and to the east of us. Wind blows from high to low, generally speaking. And that means an offshore flow. The offshore flow comes down the mountains. It gets heated by compression. And so it's as if we're on the other side of the mountains now, the rain shadow side of the mountains, until the Santa Ana wanes, which will probably be sometime tonight or tomorrow, and the sea breeze comes back. So in the meantime, the point is that we're getting this offshore breeze, downslope flow, heating by compression, and that's your 80 degrees and 90 degrees and some of the records that we've been setting. Not really unusual for fall that we have Santa Ana winds and such warm temperatures. Anyway, the other reason why I wanted to show this is if you look way down off of Mexico, you can see all these big storms forming in this infrared image. And that's the energy that our storms are going to have to tap into. They're going to drop down from the Gulf of Mexico, as they usually do during the winter, And in their counterclockwise spiral into California, they'll scoop up that extra energy and moisture from over those hot El Nino waters. And that creates a really unstable situation. And then we go back to the years, like you said, 82, 83, 97, 98. And we were waiting then too. And when the storms came, nobody asked anymore, where's El Nino? So here's the problem, everybody. We've got 2 years of data sets where we had El Ninos this big, and that's not a big enough data set. And so there's a lot of risk here in trying to predict that we're going to have big rains and flooding. But the 2 years that we've had El Ninos like this, we've had big rains and flooding. So that's what we're expecting. You can kind of watch out for this sometime in December. And of course, January and February are typically our wettest months anyway. So that's when we're expecting this. So there's 3 websites I wanted to show you because I don't have time to talk about them all. The first one was the NOAA El Nino update. You can Google that and get that. Anybody can get that. The second one I showed you was the National Weather Service Forecast Office, which is in Oxnard. It covers this whole area. And so you can go online and get the latest weather information whenever you want. You don't have to watch the circus on TV. And then to find out what's been going on in the, as far as climate change goes, you can go to this NOAA, National Center for Environmental Information, and go to the global summary for October. You can see that here. And if you skim down, let's see. We have another thing the global, and oh, here, let's push submit, or if you could click submit on there. So it says Global Analysis 2015 October, and then we're going to hit that first one, and I think I can carry it from here. Okay, so a couple of other stats I wanted to show you. This is a little bit light, but it shows the hottest months in the history of the world since the late 1800s, all right? And the hottest month in the history of the world since the late 1800s is last October. Second was last September. Third was last March of this year, January 2007, February 2015, June 2015, August 2015. These are all the hottest months ever recorded globally. That's from pole to pole since the late 1800s. So I think I see a trend there. Now let me see if and I wanted to show you this graph, again on the same website. And let me skim up a little bit there. And what you can see are all the hottest years ever recorded since we started recording in the late 1800s. And, well, let's see, it's 2015, 2014, 2010, 2013, 2005, 2009, and 1998 got in there too. But if you look at that top curve, that's this year. So that every single month that you see here has been far warmer than the warmest years ever recorded globally. And you can see that the trend is not going in the right direction. So let's give 2015 a round of applause and just say it's the hottest year we've ever recorded in history. Go ahead. You can give, yeah. So one more, and then I'll be done. Don't worry, Catherine. Let me go back again. Again, you can get all this right off their website. And I wanted to show you one more here. How many people have heard of the pause? And the only reason why I'm saying this, it was on TV a couple of weeks ago because there was a particular senator from a particular state called Texas who was talking about some kind of pause in the warming trends. And this goes back all the way to, what is it, I can't even read it up here. But each year is shown as back to the 1980s. And you can go here and get to the 1998. It's right here. You see that one month in 1998? So some people look at that and say, oh boy, that was a real hot year. We haven't heated up very much since then. But remember, these are global temperatures. Does anyone see a trend here? Is every year hotter than the year after that? No, but it's a trend, and that's the trend that scientists and climatologists are looking at. There has been no pause. In fact, as we get toward 2015, of course, the trend is going up even faster. So here's the way it works in a quick nutshell. We have slow periods of warming over the last, since the 1800s. And then we have an El Nino year, and we get very fast periods of warming. Then we'll have slow periods of warming, followed by fast periods of warming. We've just ended a slow period of warming. We're now in a fast period of warming, so put on your seatbelts, everyone, because when you combine everything that's going on, the El Nino year with the changes in temperatures that we see, and by the way, I know Belinda wants me to do this. Everyone give a round of applause for carbon dioxide content. We're over 400 parts now per million, 400 parts per million. And that is the more carbon dioxide than we've had in our atmosphere in over 800,000 years for sure. I'm really excited about that. And you all know where it's coming from. We've covered that in other events before, and I think, Belinda, I should be quiet now. I think I've given them enough data to work with. What do you think? Okay? All right, there you go.
You see now, yeah.